First thing is I need you all to have your sketchbooks with you and your pencils because you will be writing a lot of notes today. Okay. I'll go slowly because it's the first lecture. It's a new material that we're talking about. It's a new type of construction that we are looking at. So I'll go slowly. Okay. You can interrupt me and stop me wherever you feel like and ask questions. Okay. Now tell me if you can see my screen. Can you see my screen?
Yes.
Is it on full screen mode or has it gone on a presentation mode?
It's full screen now.
Okay. Yeah, so like I said, we're going to start off with looking at a new material in construction, and that is steel. When we say steel, we are mostly talking about mild steel. But how is it that we came about uh, to using this material, right? So the first thing that comes to our mind when we talk about steel is generally iron as well as steel together, right? So this iron and steel frame had a sort of radical or a revolutionary effect on the way that designers started thinking about buildings. Okay, so this kind of this kind of say skeletal frame became the armature of the modern movement because it released the building as we knew of it earlier, right? And it released the building from the inhibitions of the load bearing wall and the trabeated construction. You remember that from the first year, right? We have spoken about heavy masonry walls, we've discussed the bonds, and we spoke about trabeated construction, which is generally uh, the post and lintel and the arches, correct? So this kind of frame set historical precedents for thinking and theorizing about architecture based on this skeletal frame. Now, the example here that you see, uh, the first kind of outstanding example was the building standards set by the Sung dynasty. Okay, not very heard of, not very prominent, but they were the first to kind of create a building standard which spoke about using skeletal frameworks, right? But this sort of didn't create a lasting impact on this development of this kind of building technology, right? This example that we see here, you can write it down, is the small Stave church in Norway. Okay, it's a small stave church in Norway, which also used this kind of skeletal framework. And like I said, they didn't sort of create that kind of lasting impact that we would have probably expected. So architecture theories were still very deeply rooted in the trabeated kind of tradition, and it was only then when Mises' kind of mild steel examples that proved potent and became a driving force behind the revolutionary frame construction or buildings. Okay. Now, it is not that frame construction didn't exist. Write down this next example. This is the Derby Cotton Mill. Okay. This is a mill building. Yeah. So it's not that frame construction didn't exist. The timber frame construction we've spoken about, we've done examples, you did an exercise in the first year with the timber posts and joists and binders and all of that, right? So with these mill buildings, we can see timber frame construction. But what happened here is then you have to deal with the aspect of fire wherever timber is concerned, correct? So this building had brick arches which spanned the heavy kind of timber beams, and they were supported with cast iron columns. Now what you have to understand about this material of cast iron is the fact that cast iron is very good in compression, right? Why do we use a material as a vertical member to carry the load downwards is because that material displays very good compression quality, correct? Which is why cast iron columns were used in this building. And the concern with this kind of construction was primarily protection of the building from fire. Okay, and therefore then it so happened that this person, please write down these names. Okay, all the names that I am mentioning, please write them down. Charles Babbage, he first introduced cast iron beams into this frame of this building called the Shrewsbury Mill. You must have heard of this word, Shrewsbury Mill. Okay. In this building, then, it was the first time that cast iron beams were used. So you can see this. There were various designs of the beams. It's not a very clear picture. You can probably look it up on the net. It's cast iron beams in Shrewsbury Mill. Okay. So another, say, characteristic of this material is that cast iron is brittle. Okay. Yes, it has very good compressive strength. Now you're going to see this statement in a whole lot of slides. I've repeated this in many of my slides just so that it sort of stays with you. Okay. So apart from the fact that it is good in compression, it is also brittle, okay? And therefore, that's how they then started moving from cast iron to wrought iron, and then you still keep the cast iron columns because it's good in compression, like I said, and you move to beams that are made of wrought iron. But this is the first kind of building that started using cast iron columns. This was built in 1796. So just think about the period that we are talking about here. Okay. Now, despite the fact that they are using this frame construction, they're using cast iron columns, they're using beams, what you also observe is that the external facade of the building or that sort of envelope of the building still happens to be constructed in masonry. There is still this kind of heavy kind of facade that comes to your notice, because in spite of you seeing a very lightweight kind of construction happening within the building, and they are actually carrying the load, they haven't yet broken out from the fact that the building can actually just be steel and glass, or just be steel and some light brick. They still have that, they feel the need of having this kind of masonry appearance. Okay, they've still not broken away from that. And this building now, this boat store, okay, which is a naval dockyard, then became the seminal building, or one of the first buildings that caused this kind of revolution. Okay, so you can take this name down. So this became the seminal building of the modern movement, but you're still retaining the masonry construction. Okay. Now this building that you see here is the Ritz Hotel. Okay, you can write that down. This was constructed in 1909. This also allowed for a steel frame and panel construction, but like I said, this sort of still kept the look of a masonry construction, right? Now this structure here is a station. This is a cast iron column with these kind of cast iron beams, or it is a composite kind or a built up kind of a truss that we see here. Okay. This building is the Malvern Station. You can write that down. Malvern. Okay, that's a Malvern Station. Here again we have a cast iron capital. So try and understand and see that they're still not moving away from the appearance of the column. It's still looking like one of those classical kind orders, right? This appearance has not moved away into becoming just an I-beam or a C-section or a built-up C-section or whatever it is. It still looks like one of those classical orders, right? So they've not moved away from that, but they've actually gotten into using this cast iron material. They've gotten into using this built-up truss, where these are all resting on this vertical member. Okay, so this is something which you need to keep in mind. This is where they actually began with the use of these framing members. Now, some of the sections that you can see here, these were all cast iron beams, and they actually got into manufacturing cast iron beams of different shapes, as you can see. Okay, can you sketch this out? I'll give you 2 minutes to sketch this out. So it was like I mentioned, the Ritz Hotel was constructed in 1909, and it was actually advocated by the London County Council. So they came up with bylaws that spoke about frame construction, right? So there was actually like a revolutionary kind of movement at that point of time. Now, it's not that large span structures were not seen. We know of the Gothic churches, and you're aware of these cathedrals, which had really, uh, the heights of those structures were very large. The spans were very large. So it's not as if all that didn't exist. It's only the fact that you're moving because of industrialization. Now you're moving from the use of one material to another, and you're also talking about safety when we speak about timber in comparison with cast iron. Have you finished sketching?
Was fire control any kind of reason that they were also moving away from timber construction? Because a lot of the world
Wait,
wars
I
had like
really, one sec, I
firebombing.
really can't hear you. 1 minute. Let me try this. Yeah, can you repeat your question, Shravan?
Were there any fire risks that also kind of push the requirement for steel structures? Because
Yes, precisely. It was the fire in the mill that got around to, getting them to think about using different materials.
thank you.
Are you done sketching? Can we move to the next slide? Anushka, have you finished sketching?
Yes.
Okay. So let's move then to the next slide. Of course, I'll post the presentation on Teams, so you'll have the presentation with you. Now we're going to look at these different kind of examples and how uh, different kind of construction explorations took place with the use of this material. You're going to have to write down these examples. Uh, I've not put everything up on the slides with the intention that you guys will write things down. Okay. This is uh, a library. Okay. Does anyone recognize it?
Has this been featured in the movie?
Which movie? Can you guys
think,
still see my screen?
yeah.
Okay.
The top left one, right?
Yeah.
It seems familiar. It seems very familiar to the library that was in this is the climate change movie. The day after, no, the day after tomorrow. Was it? The
Oh
one where
yeah,
everything's freezing
day
over.
after tomorrow, maybe. Yeah, you're right. Could be. But this we've shown you in the first year also, right? When we've spoken about arches and domes and all of that. Yeah. So this is the
Oh,
National Library in Paris. It's called Bibliothèque Nationale Paris. Of course, I don't know how to pronounce that. So write that down, National Library in Paris. Now, what is it that we observe here? What do you think are these materials? Can you see the slenderness of these columns? Can you see how slender they are? They're not like the huge piers that we saw at Gloria Church, right?
yeah.
Correct? So these are now cast iron columns. Okay? But the domes here are made in wrought iron. And the way that the domes are constructed are making use of plates. Can you see this? Each one is a wrought iron plate. And they have been put together to create this kind of dome. And this wrought iron dome, the load of this dome is now moving down to the cast iron columns. Okay? Have you got it? Have you understood?
Yeah.
Okay, these plates are all riveted together. Okay, so that's how I probably think they want to camouflage that and they've created this kind of pattern around it. Okay, so this is a complete new style that came up. Now the columns are cast iron, don't forget. These are cast iron, but these plates are wrought iron. I'm specifically not going to talk about aesthetics and anything over here. We're talking about the way that construction moved, okay, how they progressed from using cast iron to wrought iron to steel, okay. So this is the way they did it for this National Library. Now, this is an aqueduct. I really don't know how to pronounce this. I'll give you the spelling. It's Ponty. I'll put it up on the chat, I think. I don't know how to do that once. I'll just write it on the chat. Okay, this is an aqueduct. I'm pronouncing it as Ponty Silt, okay? I'm not sure what it is pronounced as. In this case now, if you can see, again you have these plates that are all riveted together. Can you see this? Can you see this? These are no longer masonry arches. Okay, so that's the way that this construction has taken place. Okay, this is cast iron and stone, right? And of course, it's really very simple in construction, but it is very elegant. And look at the kind of spans that we are talking about now, right? So this is a different style of construction. This is a different style of construction. And of course, it's a complete different structure, right? We're looking at a library here. We're looking at an aqueduct. Then we're looking at a bridge here. Anyone recognize this bridge? I've not put the name here, I think. This is called as the Tubular Bridge. Yeah, you can write that down. And the architect is Francis Thompson. Right? Now, what is so special about this tubular bridge is what I've written down here. This consists of twin rectangular iron tubes running through three masonry support towers. Okay, so these are the three towers, and you have these iron tubes that are running through them. And then there are abutments at either ends over here to take the load from here, right? Of course, this then got dilapidated, and now they have steel kind of arches here that are supporting the bridge, but that's fine because we're looking at construction in 1814. Okay, right? Now, can you recognize this? This is the Great Stove, okay? And it was designed by this famous person called Joseph Paxton. I'm quite sure you must have heard of his name. Have you heard of his name?
Yeah.
Yeah, okay. So this is now cast iron as well as timber as well as glass. Okay. So there are again influences from classical and Gothic that are coming into this, but otherwise it's really quite postmodern in that sense. Okay. Have you written all this down? So what we can safely say is that industrialization led us to the use of lighter materials. There was prefabrication that is taking place. There's assembly that is happening on site, like over here, there's riveting that's taking place inside. You can see large spans. There's transparent envelopes that you can see, stained glass windows, started using wrought iron. If you remember Gloria Church and if you remember Ainsley having told us that the stained glass all came together with this wrought iron between the stained glass pieces, correct? And so that means we are trying to stretch the use of this material to its limit. What is the maximum that I can use the material to span, right? What is the maximum height I can achieve with the use of this material? So we're actually stretching this material to large limits, okay? And of course, yeah. I can't hear you. Can you type it out in the chat? Hello, did someone say something?
I think that was by mistake.
Okay, so I'll continue. Yeah, so of course, when we're talking about large span structures, we are most definitely talking about bridges, right? So again, you're going to have to start writing down these examples. Bridges were the best examples to cite when we're talking about the use of cast iron and wrought iron. This is the Brooksdale Bridge. It's called Cole Brookdale Iron Bridge. Okay, so this is constructed with the assembly of these cast iron elements that you can see here. Can you see these? These are all cast iron. Okay, and cast iron components creating this kind of semicircular arch. Now these elements, as you see, are all individual elements. So there is this piece here, there is this piece here. Each one is a separate element, a separate piece, which is then put together with the help. Now this is not riveted. This is put together with the help of pins and bolts. Write this down, please. They have used pin and bolts. Pin is PIN and bolts. Okay. And this span that you can see here is 100 feet. Okay. So that means there is this kind of technological ingenuity which puts these components together to create the span of 100 feet. Okay. So that's a remarkable achievement in those times. There is a high level of accuracy, high level of workmanship, high quality of workmanship, and Again, this thing is when we talk about an arch, we know that we're talking about members that are always in compression, correct? So they're compressive members that have been put together. Please say something. Yeah, I'll type the name over here. Brooksdale Iron Bridge. Then this is the fourth bridge. This is called the fourth bridge. I have an enlarged image here just to explain to you what these members look like close up. Okay. So this is a kind of complicated assembly of these members. These are tubular trusses. Okay. So these members are all tubular, circular, hollow, right? The tubular members that have been put together to get these kind of cantilevered trusses. These are all cantilevered. Can you see that? They're supported only at these 4 points. So these are cantilevers, these are tubular members that have been put together to create this kind of truss. These are riveted and bolted. Okay, write that down. It's fourth bridge and it's riveted and bolted. As against this, these were pins and bolts, while these are rivets and bolts. Okay. This is the same thing that we saw earlier, the boat show. This is from outside. Okay, the mill building that we were speaking about. This is the boat show building, and what I want to bring to your notice here is this kind of modular construction. So this is one bay that you can see here, and the same bay has been repeated. Okay, so that's what I want to bring to your notice over here. Did you write that down?
Yes.
And this is also multi-storied, okay? Another aspect of this is that it is multi-storied. Now in this case, you have cast iron columns, you have beams, they're supported, the beams are timber joists, you have wrought iron plate girders, and they're spanning 30 feet. So each bay is 30 feet. So this is very similar to a portal kind of a structure, what you would call today as a portal. Okay. Did you get that? Can we move on?
Mamta, wrought iron is used for which member in the board store?
Wrought iron are the beams here. Cast
Okay.
iron are the columns.
And timber for?
Timber joists.
Timber joist. Thank you.
Sorry, and how are they joined?
Let's go to that slide.
Was bolting was not done till this point, right? If it was
Yeah.
Hmm.
No, these are the traditional kind of rest. What do you call this one? Simply supported. These are all simply supported. This is the inside of the same structure. Now from here we come to what is called as the Chicago style. Okay. which is I think like one of the cities or first cities to have what we call today as skyscrapers. So it was considered, this place was considered, the Chicago style was considered to be the cauldron of ideas where these new materials have started coming together. So it at that point of time it had the most number of tall buildings compared to any other city in the world. Okay, this is late 1800s. Now, if you look at this, this is called the Reliance Building. You can write that down again. And again, putting steel and glass together. Now, this building was a building that sort of replaced an original building over here. So they had actually supported the upper part of this building. Okay, so that's very unusual with this. This was a building which was given out on lease actually, and the leases on the lower floors had run out. So वो खत्म हो गया था. So what they did was they supported the entire upper part of the building, and then they demolished the lower portion of this building, right? These upper floors were supported by screw jacks, and that's how they carried out the construction of this. So it is said that they took only a fortnight, that is 14 days, to put up this skeletal framework, and the entire exterior they completed within 6 months. So imagine the era that we're talking about and the speed of construction that was possible with this kind of use of materials and this kind of construction. Okay. So it was really fascinating for the people in that era. Okay. Now, before we go on to, I want to show you like some short clippings of a movie, video clippings. Before we move on to that, I just want you to write down some examples, okay, for you guys to look up. Look up the Eiffel Tower, which is a great symbol constructed in iron. Look up King's Cross Station. Are you writing this down?
Yeah.
Look up these examples and try and understand how they have been constructed. Okay. Look up the staircase in Hotel Solvay, Solvay. That's in Belgium. Then look at Karlsplatz Station, Vienna, and this famous architect called Otto Wagner. The post office also by Otto Wagner, you can look up. And then look up the Crystal Palace, again by Joseph Paxton. Now, I'm going to show you these.
Mamta, can you repeat those names? I'm sorry.
Yeah.
You could not get those.
I'll repeat. First is the Eiffel Tower. Then is King's Cross Station. Then look up structures by Otto Wagner. That should be enough. So the post office building, I think, is a good enough example. Yes. Good, you're putting it up here, Ravi. Now let me hunt for my movies. Can you still see my screen?
It's on the same
No,
PowerPoint.
it's on the PowerPoint.
It's on the PowerPoint. Okay. So I should. Here. Yeah. So now I don't know how to do this. I hope we can all see this together. I'm going to be playing the movies from here, and I want you to watch it with me, and I want you to write down some points. I'm definitely going to be asking you some questions. These are 4 or 5 short clippings of 4 or 5 minutes each, or maybe a little more. which talk about the construction of Crystal Palace and how it came about. One of the large span structures constructed by, yeah, Otto Wagner's right, by Joseph Paxton. And that will help you to understand how this kind of technology has come about. Okay. So again, I'm going to share my screen. Hmm. Tell me if you can see it or no, okay? Can you
I
see
can
it?
hear I can hear the audio, but I can't see anything beyond the file explorer.
Okay, I'll share it again. Now can you see the screen?
Yes.
Yeah. Yeah. There's no audio though now. I think you forgot to add computer audio. Maybe.
My name is Antoine Picon. I'm the G. Ware Travelstead Professor of the History of Architecture and Technology at Harvard Graduate School of Design, where I teach classes in the history of architecture, urbanism, and technology. Few buildings have marked as important a moment in the history of architecture as the Crystal Palace. Not only was the building emblematic of a new way to build, using iron at a scale unprecedented, it was also a major turning point in terms of its use, since it hosted the first World Fair and introduced a whole new spatial experience. The revolutionary nature of the building was immediately felt by the contemporaries. Not only was the building immense, but it introduced the public to the new realm of merchandise, to this capitalist world full of wonders. As some critic of the time wrote, the building seemed as large as the entire planet. This class is about the changes brought by the first industrial revolution to architecture, but both to the production of buildings and to their use. As we will see, the Crystal Palace is indeed emblematic of major changes in construction with the adoption of iron, as well as in the perception of architecture. To understand the scope of the changes brought by the Crystal Palace, it's necessary to say a few words on the progress of iron construction. Of course, iron had been known for thousands of years, but its use at a massive scale in construction really started at the end of the 18th century. In 1779 was, for instance, constructed the first bridge entirely in cast iron in Brooksdale in England. Later, iron would develop both in very utilitarian construction like bridges, but also in more pleasurable venues such as greenhouses. As we will see, greenhouses have an intimate link with the conception of the Crystal Palace. Here we have the interior of Kew Garden Greenhouse by Richard Turner. Today, we find the use of iron totally normal in construction. We tend to forget, by the same token, that this was not the case prior to the 18th century. Iron was used mainly for machines, for guns, for cannons, but certainly not in the very large quantities required by iron construction. The modern story of iron in buildings and infrastructure really begins during the second half of the 18th century. The Crystal Palace was built to host the first great exhibition that opened in 1851. The Great Exhibition was unique because it was the first worldwide show of that size, but it was actually rooted in a longer tradition that really started in the 18th century with a greater and greater interest taken in technology by all European elites. The Encyclopedia of Diderot and d'Alembert was typical of this interest for technology in general, with its very minute description of fabrication, like here, for example, pin making in an 18th century factory. This interest led the European elites to try to organize exhibitions showcasing the industrial production of their respective countries. The ambition to showcase the products of national industry was especially pronounced in France. In 1798, a first exhibition was organized in Paris, and later on, exhibitions of that type were regularly organized in the French capital. The last one of these exhibitions, the one preceding immediately the Great Exhibition of 1851, was a pretty massive endeavor hosted in a large temporary construction near the Invalides, right in the middle of Paris. At the time, the term industry actually did not cover only manufacturing, but also all the human activities related to technology. Also noticeable was the presence of agricultural product. In 1849, for example, cattle was displayed along with machines. So this related really to the 18th century sense of industry as everything linked to the productive activities of man, and not only manufacture as we know it today. As we will see, this extended meaning will characterize still the great 1851 exhibition.
Can you still see the screen for the next video?
No.
Okay. Now,
Yes, we can see it.
Yeah, yeah.
(1849) provided the incentive for the organization of the Great Exhibition held in London a couple of years later. Indeed, Great Britain was at the time the most advanced country technologically, but also in economic terms. So how could it be that England had not organized an exhibition of this type? The idea was actually taken by a small group of people belonging to the Royal Society of Arts, a company that had been created in the 18th century and had been revitalized by the presence of Prince Albert, who had become president of the society. Here we have a painting depicting the main protagonist of the organization of the 1851 exhibition. In the center, we have actually Prince Albert sitting, and the people pointing a finger towards the paper in front of the prince is actually Joseph Paxton, of whom a bit later. So the society, it's in the middle of this society that this idea to organize something at a much larger scale than what had been done before gradually emerged. So first, One had to find a land where to hold the exhibition, and Prince Albert actually secured the temporary loan of part of Hyde Park as the place where the exhibition could take place. Other members of the society were extremely active, securing promises of artifacts to be displayed. The secretary of the society toured the United Kingdom, visiting industrialists in order to obtain those promises. What was gradually emerging was a very large project. Overall, the estimation was that something like 800,000 square feet would be necessary to host the entire exhibition. Hence, the idea to call for a proposal for a very large building in order to be able to shelter all the artifact that would be displayed. A committee was formed and asked for proposals to architects all over Europe. The call was issued in March 1850, and a couple of months later, some 230 proposals were received, most of them from the United Kingdom and France. Two proposals were especially noticed. The first one by a French architect, Hector Aurot, a kind of gigantic shed, very much like a railway station. The second one from Richard Turner, an engineer who had recently realized the Kew Garden Greenhouse. Both proposals were admired for their qualities. They were both actually proposing a single building, something that would be retained by the committee. In the case of Aurot, this inspiration would later lead him to his utopian project for covering the Grand Boulevard in Paris with iron sheds. We can see there the genealogy between the world of the Passage, the Great Exhibition, and subsequent development in an urban iron construction proposal. Some 230 proposals for the Great Exhibition buildings were exhibited in London in the Institute of Civil Engineers in June 1850. From those proposals, especially from the two most noticed ones, the Hector Aurot and the Richard Turner ones, the committee drew a number of conclusions. The first one was that instead of conceiving a series of separate buildings, it was probably much better to imagine a single building, which would give more flexibility, a flexibility all the more needed that the definitive organization of the exhibition was not yet known, especially since all the loans had not yet been secured. Another idea related to this single building choice was to conceive it in a modular way. And this is where the idea of a module of 24 feet began to emerge as probably the most convenient choice. The committee had a number of architects and engineers, and since no proposal had been deemed completely satisfactory, the architects and engineers of the committee decided to design their own proposal following, these general choices: single building, a grid on a 24-feet module. What the result was actually a pretty horrendous proposal made of brick with a giant dome that would have dwarfed the St. Peter's one, but which proved not only ugly in the eye of the public, but also highly problematic since it entailed a massive production of bricks that would have then to be demolished. At this stage, the organizers began to doubt that they would ever be able to organize the exhibition. Not only seemed the scheme completely unpractical, but the money to build it seemed difficult to secure. The public, in addition, was growing more and more skeptical about the idea because of the images that had been shown in the press, such as this one. Prince Albert itself was beginning to despair. This is where Joseph Paxton comes into play as, in some ways the savior, a kind of superhero like Superman, who's going to really redeem the situation and transform what was a path towards failure in one of the greatest achievements of the early 1850s. Joseph Paxton is a kind of quintessential British hero of those years, insofar that he had no traditional training. He was neither an engineer nor an architect, but actually somebody who had risen pretty much by himself. Queen Victoria was to call him a gardener in a dismissive way in her memoirs. Actually, Joseph Paxton was far more than a gardener. He was somebody indeed interested in botany, but somebody who'd realized construction of all kinds, somebody also who launched press enterprises. He created a couple of journals. And above all, and that's true, he was a gardener in that respect, he had become the chief gardener of the Duke of Devonshire and responsible for the management of the main estate of the Duke in Chatsworth. Chatsworth was a magnificent castle, but it hosted a very large botanical collection. The Duke himself commissioned expedition to bring tropical species and acclimate them in Chatsworth. If Chatsworth is mostly known today for its beautiful grounds, it was also a highly experimental place where Paxton realized in particular two experimental greenhouses which will play a role in the initial design of the Crystal Palace. Paxton's main realization in Chatsworth was the Great Stove, a giant greenhouse started in 1838 and completed in 1840. It was at the time one of the largest greenhouses ever built. The Great Stove was not only important because of its dimension, but because also of a number of technological achievements, among which the use of very large sheets of glass, very different from the smaller pieces that had been used before Paxton. Paxton worked actually in close relation with the Chance Brothers Company, a company who produced glass, and actually the Chance Brothers Company will be working for the Crystal Palace. The Great Stove has disappeared today, but it was much admired by the contemporaries, among other things, not only because only of the technology, but also its sheer size. You have to imagine that it was as high as the vaults of a Gothic church, something quite impressive, which enabled the greenhouse to host trees inside. Here we have, for example, a drawing made by a German architect while touring Chatsworth, which says a lot about the kind of European-wide reception of Paxton work. So, gardener perhaps according to Queen Victoria, but a gardener of a very special and elevated type. Another key realization of Paxton at Chatsworth was the 1850 lily house that he built to host the giant lily plant called the Victoria regia. This was actually a very rapidly growing plant, which entailed actually rebuilding an entire greenhouse for it alone. There, Paxton actually used a completely innovative roof principles using much longer sash bars supported by cast iron trusses that would actually be the very principle for the Crystal Palace roof techniques. One of the key intuition behind the Lily House was that a great resistance could be achieved by thinking of structure not necessarily in terms of very large and massive structural members, but through a more web or lattice-like way of thinking. Something that was inspired allegedly to Paxton by the very lily flower he had to shelter in the Lily House. Here we have Paxton's daughter sitting on one of the leaves of the Victoria regia, and these leaves were rigidified through this kind of intricate web, which was a source of inspiration for Paxton. And the whole Lily House is actually a complex system that functions a little bit like what we would call today a kind of space structure. As we can see here, they're relatively long sash bars, which are supported by cast iron girders, but the whole thing functions a little bit like a web, which was one of the principles at work in the Crystal Palace. Here we have a more detailed view of the Paxton roofing principle, which is, may look simple, but which is full of refinement. For example, the wood beam actually rigidified through iron cables, a little bit like a truss. You may note also the grooves at the base of the wood beams. They are actually meant to allow for the water produced by condensation to be evacuated. The genius of Paxton lies not only in the general conception of his building, but also in the kind of very close attention paid to details. And as we will see, details at the scale of the Crystal Palace become no longer negligible. I have insisted on the use of large sheets of glass by Paxton, glass produced by the Chance Brothers factory. It's quite interesting that glass, which is with iron one of the most emblematic materials of the industrial era, remained relatively artisanal. It was blown. Typically, people blew cylinders that were then opened and flattened in order to produce sheets of glass. While iron, of course, knew very important transformation in terms of processing. We understand also that, a process like the first industrial revolution is actually a mix of, very spectacular technological advances and more incremental, more minute changes like those that characterize glass manufacturing. So how did Paxton enter the story of the Great Exhibition? Actually, through a series of serendipitous coincidence. Paxton actually had begun sketching. He was actually appalled by the official scheme of the committee in charge of the exhibition and imagined that actually a greenhouse like solution would actually function much better at that scale, and especially would be lighter and less expensive. He had begun to sketch, and here is one of the most famous sketches in which we find the principle of the Crystal Palace. It's a kind of cross-section, and it's a kind of giant lily house with the same roof principles, but of course at a completely different scale. Among the many interests of Paxton, one found railways. Once again, he was a very special kind of gardener, and he had become an expert in railways. And he had traveled in order to participate to a discussion at a trial regarding some kind of contentious issues on railway construction and management. And traveling back to London, he met with one of the members of the committee, Robert Stephenson, the famous engineer who had been involved in a number of enterprises, railway, but also bridges. He's the author of the Britannia Tubular Bridge. And Paxton showed his scheme to Stephenson, who got completely enthusiastic and thought that this could be the solution to the conundrum in which the committee found himself. So Stephenson did encourage Paxton to actually submit his proposal for the realization of the grid building of the exhibition. There was only one problem, which is that the call for proposals were actually proposals to build the project elaborated by the committee. Fortunately, there was in the contract, it was stipulated that if the companies, the building companies had an alternative idea that was cheaper, they could actually submit it in parallel with the proposal to build the project of the committee. So Paxton partnered with a firm called Fox and Henderson and proposed his scheme as an alternative to the construction of the committee. Paxton's proposal was roughly 60 to 80% cheaper than building the project in with brick and mortar of the committee. But it was not only cheaper, it was actually much more seductive, and the images published by the press immediately gathered momentum around what appeared more and more as the solution to the difficult problem of how to host the Great Exhibition. Let's not forget that we're in something like in June 1850, and they're barely 1 year and a half in order to complete the construction, to open the exhibition. So actually things were pretty much in rush. This image published in the press is actually the first version of Paxton project As we can see, this is a very repetitive buildings in which there is a certain indistinction between the various parts of the building, something that was wanted by Paxton. In some ways, the Crystal Palace also marks the emergence of a totally new idea in architecture, which is the idea of flexibility. An idea that we there again become completely accustomed to. Flexibility seems, a key notion when thinking in terms of very large building. But once again, this was the first time that such ideas ever emerge. Another thing to notice, there is no transept, contrary to the final buildings in which we can see a transept with a barrel vault in the middle of the building. The transept was actually an idea that emerged at the intersection of a couple of concerns. One was that the ground on which the building was to be constructed was actually leased, but had to be brought back in its initial shape. And there were a number of trees on that ground, and the British are very attached to trees, as we all know, so trees had not to be destroyed. So there was a problem on how actually to put the trees inside the building, so the additional height provided by the barrel vault was a solution, an elegant solution to that. A second role played by the transept was actually to improve a little bit the lateral bracing. It did improve the bracing, but one has to say that actually Paxton and Fox and Henderson, its builder, were quite lucky because the bracing was still pretty imperfect, and had a storm or something happened, the Crystal Palace could have been in serious trouble. This was a building very rapidly designed and with a number of structural flaws that have become evident to the eye of historians studying retrospectively how it was designed. I said that the building was enormous. It covered on the ground something like 800,000 square feet, something quite unheard of at the time. In addition to that, a second floor brought some additional 200,000 square feet. So in total, it was almost 1 million square feet, something that enabled to display all the artifact that had been secured by the committee, the organization committee for the Great Exhibition, but there again, something that one had never seen before that building.
I hope you guys are making some notes. Now we'll come to the actual kind of construction, okay?
The overall organization of the building is quite simple. It is actually strangely reminiscent of the structure of a church, with a central nave which is 72 feet large and rises at a height of 64 feet, but which is actually 4 times longer than the greatest church in the United Kingdom, St. Paul, and of course with a much thinner structure. These made a very spectacular impression on all the visitors. This is the Crystal Palace immediately after the end of the Great Exhibition, and we can see this kind of impression of infinity. It was perhaps the first time that a building gave this impression of being infinite, this repetitive, almost infinite space in which the eye got almost lost. I mentioned the trees. Here we have the transept of the Crystal Palace with one of the trees. And we are, by the same token, introduced to another theme that will play an important role throughout the Great Exhibition, which is the juxtaposition of the natural and the artificial, with a suggestion that human industry is actually an extension of a kind of fecundity of nature itself. The main entrance of the exhibition was through the transept, and people immediately discovered the trees, but also fountains, colors. I'll come back to the ambience of the Great Exhibition because this is also an important aspect that gave the building also its mythical character. Because of its scale, the building confronted its designers to completely unexpected problem. One was actually how to evacuate water, the rain that fell on the roof. Because of the surface the building covered, this problem of how to get rid of the water was actually pretty crucial. The solution adopted, which Paxton had tested, but at a much, much smaller scale in his Lily house, was actually to use hollow columns in which the water would actually be evacuated. The new thing was actually that at the bottom of the column, you found pipes that were directly related to the sewers of the city. So we understand another thing, which is that this is actually the beginning of the merging between the buildings and infrastructure. The building is so large that it becomes commensurable with the urban infrastructure as a whole. Since the construction of the Crystal Palace in 1851, this potential blurring between architecture and infrastructure has been with us repeatedly. This has been the case, for example, with the Kansai Airport built by Renzo Piano in Japan, which was at the time of its completion one of the largest buildings in the world, a few kilometers long. It's quite revealing that actually Ove Arup, when presenting, in order to give an idea of the scale of the building, actually used Hyde Park, the very site where the Crystal Palace was constructed, as if large country buildings like the Kansai Airport Terminal were actually the inheritor, and they are indeed, of this kind of gigantism that was introduced at the time of the Crystal Palace. Another interesting aspect to note is actually the kind of double level of reading of a structure like this one. Let's pay attention, for example, to the node. In order to additionally stabilize the structure, you have these giant ties that intersect, and there you have a node in the middle. Look at the complexity of the node. Of course, you don't discover it immediately, but actually iron construction will be marked by this kind of tension between the overall appearance and the details, and the secret complementarity between the two. This is something to keep in mind, is that in iron, because of the very repetitive nature, etc., detail do matter. God is in the detail, as some famous architect would later say. And Paxton is somebody who works, one again, both about the overall scheme, but also in these very minute details. In order to understand that, another buildings built much later, actually the Eiffel Tower of 1889, the overall impression is actually very much dependent of the type of node used. Here you have the typical node of the Eiffel Tower, and there again there is this complementarity between the overall impression and details that are kind of almost subliminal, but do play actually quite an important role in the reading of the structure. The famous art critique and theorist John Ruskin had a very mixed feeling about the Crystal Palace, because of course he was impressed by the performance, as if, as he said, the whole world had been encompassed by a single building. But at the same time, and we'll return to that, he was critical because iron was not his favorite material and he despised industrialization. Nevertheless, saying that the whole world could now be sheltered in a single building introduces another very important dimension of this building, which is a kind of environmental quality. This is a building in which ventilation, the control of humidity, all these questions that we think have arisen only recently were already present. You have to imagine millions of people sweating, etc. You have to imagine the heat, even in London, sometimes you can get sun, and the building can get pretty hot. So the typical problem of a greenhouse, but of course it was a greenhouse not for tropical plants, but for people. This is actually one of the louvers of Paxton. And actually the building is inseparable from problems, complex problems of ventilation that there again we take for granted, but were for the first time really addressed at such a scale. The Crystal Palace was mythical not only because of the very unique ambience it offered to its visitor, but also because of the construction. The construction is an integral part of the myth. One could even say that it was the first time that construction was really as much associated with the meaning of the building. The contemporaries were completely struck by how these standardized pieces arrived on site, were assembled. This is the beginning also of the fascination for dry assemblage. So nothing having to do with the wetness of mortar, nothing like, all these traditional construction technique, but something like a magic dance of parts, pieces, not yet machines. Horses were still the main source of power on the construction. In some ways, the Marxian notion of forces of production was probably, was almost illustrated by such a ballet of industrial components. Throughout the construction, Paxton was, of course, present and had multiple opportunities to show his ingenuity. For example, putting in place the barrel vault elements of the transept was not such a simple process. As we can see on this engraving, the barrel vault elements were actually in wood. There again, we find this complexity and this mix of traditional and more modern elements. The construction site was, by the way, really a spectacle, and Fox and Henderson sold actually tickets in order for the public to come and visit and see what was going on. Speaking of ingenuity, Paxton also designed a number of machines for easing, grazing, for all kinds of purposes on the construction site. Here we find also another interesting aspect of what the Crystal Palace was about, which is a kind of continuity between structural and mechanical engineering, something very specific to the British scene in many respects. On the continent, engineers or builders did not always imagine machines. Here, to design machine and to design a building are part of the same continuum. And this is also a very important aspect, an aspect that might explain in some ways why the high-tech expression was a product of Great Britain in the 20th century, as if, this legacy of articulation between machines and buildings had remained an enduring tradition. Putting in place the glass for the roof was also quite something, an enormous enterprise, in which, of course, risk was present. The glass could break, could fall on the workers working below, so special precaution had to be taken. There again, innovative techniques were put into place. For example, you have these little carriages on rails that enabled actually to go a bit faster when putting in place the large sheets of glass produced by the Chance Brothers factory. Here on this vision, if you pay a closer attention, you will see actually the little carriages circulating on top of the building on the rails and putting in place the glass, while on the front of the picture you have horses which are used to lift a girder of the nave. So we can see there again this mix of innovation and tradition. Mechanization would take over far later on construction sites. The result was a completely strange space for the contemporaries, something fascinating, but something that was not easy to categorize. Was it architecture? Was it something else? I have mentioned the blurring between architecture and infrastructure. In some ways, the Crystal Palace was sublime. That's to say, something that escaped usual aesthetic categories. And Paxton himself was never fully recognized as a fully fledged designer. It's quite revealing that despite this spectacular achievement, he was never awarded the Medal of the Royal Institute of British Architects, as if, the nature of what he had produced remained uncertain. This strangely repetitive, fascinating space, but was it really an architectural creation? And there, of course, we understand why John Ruskin was so reluctant. Was it still art in the traditional sense? Where was the hand of the craftsman that Ruskin praised above everything? All these traditional dimensions of art and architecture had vanished in this enchantment of iron and glass that would fascinate millions of people, but the status of which remained very unclear in the eye of the professional. One can say that the Crystal Palace marks the beginning of the split between the taste of the public at large and what professionals like architects care about. The Crystal Palace is sublime because it's spectacular in terms of size, because of the emotion it gave to the people who practiced it, but it's also something that doesn't have a clear status in terms of architecture. On this view, we can almost feel this sublimity linked to idea of infinity, of transparency, and we can also understand why people who appreciated Greek temple or Gothic churches could feel a bit ill at ease in front of such a construction that did not enter any clear category of the history of architecture. In February 1851, and note how quickly this whole story is unfolding, the construction of the building was almost complete. But what Fox and Henderson were delivering was actually a shell that had to be now accommodated for the exhibition, beginning with a big problem that had never been encountered there again at that scale, which is which color, what kind of painting in order to animate the entire buildings. The 19th century was obsessed with color. It's 19th century architects such as Jacques Kittorf, the German-born French architect, who discovered, or rather rediscovered, that Greek architecture was inseparable from color scheme. This interest in polychromy was a widely shared notion in the 19th century. So painting the Crystal Palace was at stake. But what color use? And what kind of parti, what kind of general choice in order to orient oneself? To paint the Crystal Palace, one had to move between two extremes. One extreme could have been to accentuate the immateriality of the construction, such a thin construction. Let's not forget that iron is something like 60 times more resistant than stone, which basically means that a column in iron can be 60 times smaller. So this impression of immateriality could have been reinforced by painting, for instance, everything in white. To the contrary, one could try to rather give substance to the iron. Another possibility would have been to use red, which is a color that has a tendency to make things look more closer and more present. So to paint everything in red. The color scheme that was finally chosen is actually a pretty elegant solution moving in between these two extremes. It was the work of artist Owen Jones, who was asked by Paxton and the organizer of the exhibition to actually propose a solution to paint the Crystal Palace. And here we have one of the drawings submitted by Owen Jones in order to explain his ideas. What Owen Jones proposed was actually a mix of three fundamental colors: red, blue, and yellow. Owen Jones' research and project was actually linked to also an interest in the optical and physiological properties of colors, something that had been initiated in the late 18th century, illustrated by the work of someone like Goethe with his famous theory of colors, and a question that was very much on the table in the 1850s. Owen Jones decided actually to use the blue for the web to create an impression of a complex but distant maze, with this notion that blues tend to make things recede in the background. He used the yellow as the counterpoint to make things more vividly present. And in his own approach of color, the red was kind of intermediate. The columns were actually painted in blue and yellow so that actually they would appear having much more relief, much more movement than what they had in reality. Here we can see how complex is the scheme. You may notice, for example, the girders of the main nave are in blue, but you may notice that the beam they're supporting are painted in red. So something that, once again, through a tendency to make some objects appear as receding in the background and other appear as coming rather towards the observer, created once again this impression of animation. The Crystal Palace had presented some analogies with church, or more generally religious architecture. One must not forget that in those years, polychromy was seen as one of the characteristics of religious buildings. For example, Greek temples that I already mentioned. Here we have a Beaux-Arts reconstitution of a Greek temple, and in which we see, by the way, some of the primary colors used in the Crystal Palace. So to paint was by no means a culturally neutral decision. It really was about imparting meaning to this new construction. Of course, speaking of colors, how not to be struck by the fact that this question has reemerged with buildings like, for example, the Centre Pompidou in Paris, and more generally, I mentioned high-tech architecture. High-tech architecture very often play on colors and the contrast between colors, as if a form of modernity, a form of pleasure linked to the perception of simple colored ambiances was born with the Crystal Palace and is still with us today. If painting the Crystal Palace was already a complex problem, organizing the exhibition was another. How to classify, how to bring some orders to millions of artifacts, how to structure things that range from raw materials to machines and to even work of art. Initially, the organizers had foreseen a very clear organization of the displays, an organization reminiscent of the order used in publication like the Great Encyclopedia of Diderot and d'Alembert. So the exhibition would have been organized in 4 parts, with the first one being raw materials, then machinery, so the machines, then manufactures, so basically industrial product, and then something very important throughout the 19th century, which is these industrial production that were close to art, such as, for example, stained glasses, enamel production, all kinds of things in between manufacturing and art. This very logical order created at least 2 problems. The first one was that actually the 4 sections were not of equivalent size. Second, such a division blurred national distinction, which was clearly something some nations did not want. The final organization was actually a compromise. It was a compromise in which national logic emerged very strongly. There again, there is in this building almost something emblematic of this new and very spectacular rise both of nation and internationalism. It was an international exhibition, but an international exhibition that showcased the industry of the various nations. The United Kingdom and its colonies occupied pretty much half of the exhibition. This is what you have on the left. And on the right, the rest of the world, which pretty much reflected at the time the difference between the industry of the United Kingdom and the industry of the rest of the world. At the time, England still produced something like half of the iron production of the world. So this is by no means far-fetched in many respects. Now, in order to have some logic in the way things were displayed, a number of choices were made. Machines were grouped on one side of the buildings. On the other side of the building, one found raw materials. And in order to make the exhibition more spectacular, the most interesting and spectacular artifacts were grouped actually in the nave, so that the final organization was a kind of compromise between national, thematic, and in some ways a logic of spectacle. And this is what made also the exhibition quite a success. Here, a couple of photographs of what was on display, especially in the nave. Some of these artifacts may seem purely artistic, like the dome that is in the rear, but which was actually a very large piece of iron produced by Brooksdale, the place where the first iron bridge had been built at the end of the 18th century, and which epitomized in the way the supremacy of the English ironworks. In the front, you have actually a lighthouse lantern, which was there again, something pretty high-tech at the time. And you can see sculptures, you can see a whole mix of objects, which are pretty typical of what may have looked at the time as a bazaar at the scale of the planet. I just showed you the British side. Now we have the rest of the world side of the nave, with there again a number of artifacts kind of surprising. For example, the two statues of horses that were presented by the Duke of Württemberg, which are clearly not industrial, but in between industry and traditional craft, as many of the things displayed. I won't enter into all the details of the organization that was necessary to receive all these objects coming from the entire world, to organize them, to sort them, etc. Let's just say a few things. You know, a number of people, pretty much all kinds of resources were mobilized. The military, for example, troops were used in order just, you know, to check in objects. There were so many of them. Also to mark things on the floor and to be sure that things were following the proper order and were brought where they had to be. But also all kinds of curators, geologists from the Natural Science Museum, artists, etc., specialists of the history of art were mobilized. You know, the whole London was busy cataloging, putting in place the artifacts. Despite that, and although the organizers had announced that no object would be allowed to enter the Crystal Palace after the official opening, actually it took a few weeks more after the opening to put everything in place. There again, the most formidable museum that the planet had ever seen was put in place in a few weeks, probably not completely on time, but quite an achievement, which is as much about logistics than architecture than the rest of the things we've been evoking so far. Between the 1st of May, 1851, and the 11th of October of the same year, day on which the exhibition was declared officially closed, some 6 million people visited the Crystal Palace. 6 million people might not seem enormous by today's standard. At the time, it was completely unprecedented. Let's also remember that it was a transcontinental exhibition. Artifacts came from Asia, from the Americas, pretty much every part of the world. So in some ways, one could say that 1851 and the Great Exhibition was the first global event. Here we have a caricature of the journal Punch, which is titled "All the World Going to See the Great Exhibition of 1851." And in some ways, this was actually pretty accurate. The exhibition was also an event in which social classes were a bit blurred. It was not only global in terms of being international, it was also global because peasant, worker came along with aristocrat, with the bourgeois. And here you have another caricature with people gawking at all these marvelous things. There again, we've got completely accustomed to this kind of spectacle, but just try to be for 5 minutes someone from 1851. You had never seen a building that large. You had never seen so much glass, so much light, so much transparency. You entered actually through a pretty cramped door, but then all of a sudden the magic operated. You found yourself under this magnificent glass dome in a kind of church of crystal with trees, with fountains, with this kind of mix of artificial and natural object. And this was only the transept. You've not yet discovered the whole thing. And then you arrive at the middle of the transept, and then the two sides of the nave, the great nave, appeared, this magic world full of fascinating object. The whole thing was an enchantment. It was a kind of magic world, the first Wonderland, in a way the first theme park. And as we will see, Paxton did actually envisage something like a theme park in his later version of the Crystal Palace. So there again, we find this idea of a kind of giant entertainment for everyone, mixing classes. And this is probably also the great ambiguity of the industrial world that arises at the same time. That's to say, a socially stratified world in which capitalists are more and more capitalistic, but also a world in which the spectacle is for everyone. It was a magical world, a world full of objects, of things, of stuff. This is where, to use a kind of Marxian grid of analysis, this is where the realm of merchandise begin to emerge. All this stuff accumulated, and of course with a pleasure that has to do with the never exhausted desire to see, to possess, to touch, to experience. A world in which, by the way, repetition and uniqueness go together. We have again the horses of the Duke of Württemberg in the middle of all these repetitive girders and columns. You know, this world in which would invent psychoanalysis to try to understand what was at stake in this endless mix of repetition and uniqueness, desire and monotony. Walter Benjamin, the German late 19th century, early 20th century German philosopher, wrote a number of pages about the flaneur and how Parisian it is. But one must imagine that actually the flaneur was as much a London creature, one of the visitors of this world contained into a single building, as Ruskin would have it in the moments in which he did not find the whole enterprise completely disputable. The Crystal Palace and the Great Exhibition played also a seminal role in the development of the new design ideal of the industrial world, among which we found the desire to return to a quality of craft that industry seemed to challenge. Such was, for example, the meaning of the medieval court organized by Pugin, in which the idea was to suggest that one could reconcile the industrial age with the quality of former ages, beginning with the craft of the Middle Ages. Many of these artifacts can still be seen today in the Victoria and Albert's Museum, where they have been carefully preserved. I mentioned the role of craft. Here is the section on stained glasses. Let's not forget, by the way, that the 19th century built hundreds, if not thousands, of churches. And stained glasses, was stained glasses a craft or an industry? We are there confronted with another of the ambiguity of the industrial age. Here we see again this strange world of, magnificent, surprising object. Something almost, of course, this is not yet the period of department store, but we can understand also the continuity between the wonders of 19th century department stores and a place like the Crystal Palace and the Great Exhibition.
So I hope you guys got it. He was talking about cast iron being 60 times stronger. So I think you guys should be paying attention, to these kind of details that he's speaking about. Very similar to what you are doing in ideas. If you see in an actual architectural project, all of these disciplines come together. So he's thought about uh, how the rainwater is going to be drained from the roof. He's thought about the ventilation. He's thought about the assembly of all the members. So there's so much of attention paid to each and every aspect of the building. Okay. I think after that it's only about, let me just check. It's about after the exhibition. I think we can watch it. That will be the last of the videos. Then we can take a break.
At the beginning of October 1851, the exhibition was declared officially closed, and the problem then arose of what to do with the Crystal Palace. Here we have another caricature showing the dispersion of the work of all nations, steam engine, but also elephants and all kinds of other things, leaving the Crystal Palace to return home. Emptied, the buildings seemed magnificent. Queen Victoria, in her journal, describes a visit she paid to the building once emptied, saying that this was so beautiful. And Queen Victoria was not super sentimental about architecture, but she declared that it was so beautiful that it was almost a pity that it had to go. For the building had been conceived as a temporary structure. But of course, the temptation was great to try to make it permanent, and proposals were made in that sense. Paxton himself tried to convince the authorities to keep it, to, for example, transform it into a giant winter garden, something in which, Londoners could experience the charm of spring throughout the seasons. And we're back to this environmental theme that I already mentioned, that has, of course, to do with the relation between the Crystal Palace design and the greenhouse design. The decision was nevertheless made to dismantle the Crystal Palace and to free the garden, Hyde Park, and to restore Hyde Park as it was before. But Paxton was definitely an entrepreneur. In parallel with working with the Duke of Devonshire, he had launched a series of enterprises, journals, as I mentioned, and a number of other things. And he decided actually to rebuild another Crystal Palace, larger, more beautiful, and to transform it into a private venue for the entertainment of the crowds. This was done in Sydenham, in the suburb of London, where he built a structure which is often confused with the first structure, although it is actually quite different. The new Crystal Palace was actually a much more complex structure, higher, with actually 3 transepts, a main one and 2 lateral ones, a kind of Crystal Palace or on steroids that was conceived as a kind of permanent entertainment place. And the genealogy that I mentioned earlier between Theme Park and the Crystal Palace is actually a reality through Sydenham, which can be in some ways described as one of the earliest theme park ever conceived. So this larger Crystal Palace did not have the crisp edges that we found so alluring in the 1851 buildings, but it was nevertheless a very large construction, better built. This time Paxton had the time to work out all the details of the assemblage, and much more stable. Actually, the building survived until the 1930s, in which a fire consumed it entirely. So this was a theme park. Here you have a painting of the time. You arrive through railways and you had garden, fountains, and all kinds of displays linked to ideas of exotic travel, travel in time, ideas that are very close to this idea of entertainment that characterize still theme parks today. Inside the Sydenham Crystal Palace, one found a mix of plantations, statues, etc. One could travel to ancient Egypt, as here, but also to Rome, Greece, etc. The new Sydenham Crystal Palace was not as strikingly modern as the first construction, probably because the hurry of 1851 made the building less ornamented than its later version. With the new Crystal Palace, there were more concessions made to the 19th century taste because one had more time to refine the design. But nevertheless, the Sydenham Crystal Palace was to remain also an icon of modernity, and it was photographed in a way suggesting a kind of genealogy between 19th century construction and 20th century modernity. As here, this is a photograph taken by two photographers linked to the modern movement in the United Kingdom. And we can see the suggestion of modernity going from the 19th century to the 20th. 1851, the London Great Exhibition, the first of a series of events that rhythm the life of the second half of the 19th century. The Crystal Palace was the first of a series of monumental construction that marked the epoch of World Fair. This was rapidly an international phenomenon. America, for example, had an exhibition in New York a few years after the London exhibition. This is the New York Crystal Palace, actually quite an intriguing structure with this central dome, but pretty much based on the Crystal Palace idea. Nowhere were world exhibition as important as in Paris. Paris became the capital of world exhibition during the second half of the 19th century, with exhibition in 1855, 1867, 1878, 1889, 1900. Here we have the 1867 exhibition, which is also the last Parisian exhibition to be hosted mostly in a single giant building. A much more complex pattern, this giant oval, than the initial Crystal Palace, but still following the idea of a world inside a building. Later exhibition would explode the single building into a series of massive pavilions, but this is another story. What's the meaning of all that? Probably, of course, these ideas of technology, progress, human industry, all these things we've seen. But I'd like to evoke a number of other themes that are linked to the rise of world exhibition. The first one is, of course, the need for symbols. And I mentioned Paris. It's quite revealing, it's quite fitting that actually the most famous Parisian monument is actually a legacy of a world exhibition. The Eiffel Tower was built in 1889 for the exhibition held in Paris that year. Technology remained throughout the 19th century a major theme of world exhibition, where the largest building of the 1889 Parisian exhibition was not actually the Eiffel Tower, but the Great Gallery of Machines, which was actually the largest gallery of that type ever built. We often keep in mind the trusses and the ballet, once again, of iron pieces, but one must not forget the ornamentation and the intricate link between ornament and structural performance that characterized world exhibition. World exhibition were super ornamental because this was also provided an opportunity to try to re-articulate art and technology, architecture and engineering, ornament and structural expression. This is actually the entrance of the Great Gallery of 1889. And as we can see, this is very different from the black and white picture we're often provided with. World exhibition also provided a way, because they became much more complex urban venues, almost like districts in the city. They provided gradually an opportunity to rethink not only of industry, but also of the city that hosted the exhibition. For example, the Chicago 1893 exhibition provided an opportunity for American urbanists and architects to test ideas that would later give birth to the City Beautiful movement. It is well known that the Burnham plan for Chicago owes something to this seminal experience, as if the city itself was becoming a giant exhibition. I've said a number of times throughout this presentation that the Crystal Palace was mythical. Part of the paradox of history of architecture is that it feeds upon the concrete objective relation between a building and its period, between a building and the social and political forces of the time. But history of architecture feeds also upon myth, because architecture is not only a question of materiality, it's inseparably about materiality and imagination. From that perspective, the Crystal Palace is definitely a very important moment. For this building actually was for a very short period, at least for the 1850, for its 1851 avatar, a material reality. It remained for a much longer time, probably until today, an important landmark in our architectural imagination.
So I hope you guys enjoyed that. Because I mean, it very clearly sort of allows you to understand this kind of movement from the load bearing to this kind of skeletal frame that we have been talking about. So what we can sum up the class is by saying that with this industrial revolution, steel was being manufactured in tons, right? You have iron and then you have steel that was being mass produced, correct? So it became one of the commonest materials, so to speak. And if you look in terms of cost, then steel was contributing to about 8 to 15% of the entire cost of the building. So it's also about a different kind of construction. So you can say that it's mechanization that is taking hold of the construction or taking hold of architecture at that time. Like he rightfully mentioned when he spoke about the new Crystal Palace, and he's talking about moving into the modern. And with the names that we mentioned while we were doing the lecture, you know that it is said that modern architecture entered Britain by the back door, because you have these European architects, Otto Wagner and the others, and Gropius, who come in from the neighboring places. It's not actually England or London, so to speak. If you, one of the examples, if you look at, is the Delaware Pavilion, okay? This is again a welded steel skeleton. It is said to be, I mean, what they described it as was a welded steel skeleton with an RCC curtain wall, okay? That was how it was described. So if you think back to our earlier semester, then you understand that the tenets of this modern architecture is that white kind of cubist or concrete phase has now allowed for a more lightweight kind of construction. Okay, so then you're getting into these kind of grids like you saw in the Crystal Palace. There are these bays. You've still not moved out from the arches, but that's also because iron is about compression. So it's good to have all the members in compression so that the load can be transferred easily. Okay, so you're looking at now an ease and an efficiency of construction. Though concrete also offered that, you're looking at this kind of ease to a larger scale and handling larger kind of spans and structure. Okay, so to conclude, we can say that it's purpose of the work of architecture in relation to its wider environmental considerations, the structure to form and cultural kind of conditioning factors, as well as a technological context. That is what we can conclude with all this that we have seen. So now what I suggest is we take, I'm not done with the class. Let me stop this. Yeah.